All right, what's going on, guys? So today what I'm going to do is I'm going to go over the apparent to actual motions, the worksheet that I gave you guys on Friday for the weekend. So there's a lot of questions. We're going to go through this nice and slow, and then you guys can always visit back on this YouTube channel. All right, so for the first page, it gives you basically a diagram. It shows that you're the observer. It gives you north, south, east, and west. And then it shows basically the movement of the sun throughout the day in the sky. So for number one, it's asking you the apparent path of the sun through the sky is caused by. So since we're going right in the middle and we're seeing the sun move across, it looks like the sun is actually moving, but it's actually how the earth is rotating and orbiting around the sun. So the way that we actually see the sun moving is because of the earth's rotation on its axis. All right. The earth, if we actually drew it, okay, since it's rotating, it's spinning, and different parts of the earth are shown to the sun. And that's why we have nighttime and daytime. So for number one, it's Earth's rotation. Now, number two, the observer has the longest shadow when the sun is in position what? So when we're looking at the sun, it gives us four different areas, okay? It gives us A, B, C, and D. And we have to see which one is going to give us the longest shadow. So when we're talking about that, let's say you're right here, okay? And the sun is directly overhead. Your shadow is going to be straight down. So you're going to have a very small shadow, okay? Now, if the sun, okay, I'm just going to change the color so you can see it. If the sun is now over here, the shadow that's going to give you is going to be going the opposite way because you're standing there. Now, if we keep going down with the sun and we say that there's no trees, nothing in front of you, you're just in an open plain, your shadow is going to be much larger because now the sun's rays are hitting you and you're creating a shadow on the opposite side. So for this one, we're looking at which location is it going to be giving you the biggest shadow behind you. So for A and C, it's kind of like this blue one where you're going to have a smaller shadow, whereas B, you're directly basically overhead of your character, and it's going to give you a shadow like this red line over here. Now for D, you're right on the horizon. Okay, remember the horizon is what you can see all the way around. So that's going to be hitting you as long as there's no, trees or obstacles in the way like buildings, and that shadow is going to basically go the whole way from where you are. So for number two, the choice is actually going to be D. Okay. What is the approximate time of day when the sun is at location C? So location C for this is what we're looking at right here. So we know that the sun rises in the east and sets in the west. Okay. So our choice is it gives us 6 a.m., 9 a.m., 3 p.m., and 6 p.m. Okay. So for this, we have to figure out which time it's going to be. So looking at this, where the sun is the highest part in the sky, that is always going to be 12 p.m. So since we know that's 12 p.m. for position C, or for position B, we know that somewhere over here it's got to be after 12 p.m. So that gets rid of two of our choices. So it can't be 6 a.m. or 9 a.m. 6 a.m. would probably be right here where it's rising. And then 9 a.m. would probably be where A is going up. Once it gets to the highest part of the sky, that's going to be 12. That's going to be noon. Now it's going back down, and we have two choices. We have 3 p.m. or 6 p.m. And for this, we would probably say it's around 3 p.m. Okay? Because then on the way down, where it's around 6 or relatively towards 9, 6 would be here, and then 9, that's where it's going to be setting again. Okay? So for 3, it's going to be 3 p.m. Now, during which month does the sun rise north or due east in the United States? So what we mean by this is since we have our axis and it's always tilted, okay, it's going to be relatively higher in the sky than as if it is the winter time and our noon is over here. Okay. Remember, the more sunlight we get, that means we're going to be in summer months. So for this, since we are due north, okay, because north is over here, it's showing you that we get a lot more sunlight. Now, if it was over here, this would be our spring and fall equinox. So this would be December, and this would be fall or September, and then spring, which is in our March, okay? So because it's so high up in the sky and we get so much sunlight, the only month that would make sense in New York State, since we're in the northern hemisphere, is going to be July. Okay. So that's for the first page. Now, if we flip it over, we got a couple more questions. All right. So it says the length of time that daylight is received at a location during one day is called the locations. Now, this is going to be the angle of insolation. Okay. So this is where the sun is coming down and it's showing us how much sunlight it's getting. Number 6 says which diagram best represents a geocentric model of the solar system. So I'm going to erase this for now. And remember, we have two types of solar systems in our history. We had a geocentric and a heliocentric. So the geocentric, okay, that was when they believed that Earth was the center of the universe and everything went around the Earth. Okay. So this was our planets, other planets that they discovered. They also thought that the sun was going around it. And then the closest one was the moon. But later on, we went to a heliocentric that said that the sun was in the center of the universe or the solar system. And that the Earth rotated and orbited and revolved around that. And then the moon only was the one that was revolving around Earth. So for the geocentric, you're trying to find one where the Earth is in the center. So for this, the only choice that makes sense with Earth in the center of the solar system is C. As seen from New York, the noon sun is... so for this, we're looking for basically where it's going to be directly overhead, okay? And since we're in New York State, okay, for this one, we have our Earth, okay? New York, remember where we live, we're about 41 degrees latitude. The sun never gets directly over our head. It's always high in the sky during our summer months, but it's never going to be directly overhead. It only goes to, so I'm going to change the colors. So we have the equator, okay, which is 0, and that's when it's usually over it, and it only goes up 23.5, and it goes below 23.5. So when it's over 23.5, that's when we're having winter time, and then when it goes up to 23.5 in the northern hemisphere, that's when we have summer, but it's never at 41 degrees latitude. So for number 7, it is never directly over our heads. It'll get high in the sky, but it'll never be directly. Number 8, which statement best describes the geocentric model of our solar system? So going back to that model, the Earth is located at the center of the model. Okay, when we're talking about the solar system, when we always thought back in the day when it was geocentric, the Earth was always in the center. Number 9, in New York State, which day has the shortest period of daylight? So remember, when we're talking about daylight, when the sun, the Earth is orbiting around the sun, we have 4 different important dates. We have December, we have September, we have March. Let's spell it right. and then we have June. Okay, and to remember the actual date, it's always the 21st. So which month is usually colder? It's December, because the sun, we get less sunlight because of the angle that the sun is moving, or looks like it's moving, because we're rotating, revolving around the sun. So the answer to that is going to be December 21st. In New York State, which day has the longest period of sunlight? So now we're going to be going the opposite. So for number 9, when we think about our seasons, the summer is a lot warmer because we have more sunlight coming from the sun. So it's going to be June 21st for number 10. And then New York State, which day has equal amounts of day and night? So for this, they give us 4 choices. They give us December, which we already said was the shortest. They give us June 21st, which is the longest amount of time that we get sunlight. So we're getting close to the longest amount of sunlight in the day. And then after that, it starts to go down again. And then March and September, they give us the choice of March, which is correct. And then they give us a random one, which is August. And August would be in the summer months where it's going down, okay? So the choice for number 11 is going to be September 21st. Okay, so for number 12, they give you the diagram that we saw before. So they give us this line, they give us an observer, okay? Basically, they give us our horizon as we go around, okay? And they say that this is north, this is west, east, and south. And they give us 3 pathways of the sun. So for this, I'm going to put this first pathway. This is path X. They give us another one. Which they say is path Y. And then they give us path Z. Okay? And they are saying that you're located right over here. So for this says, what is the rate that the sun appears to travel along path X from sunrise to sunset? So here's path X, and we're saying, how is the sun rising in the east and then setting in the west, okay? So if we remember when we were doing time zones, our time zones are always 15 degrees for every hour. So the sun is moving 15 degrees into the sky. So for number 12, it's going to be 15 degrees per hour. Now, for number 13, which path of the sun would result in the longest shadow of the observer at solar noon? So here's our 3 parts, right? We got 1, we got 2, we got 3. And this is where you are located. Remember, if you're over here, and instead we're using a flashlight, and we're shining that flashlight over your head, you're going to have a small shadow. Whereas if someone was standing right here and shining that flashlight, your shadow is going to go all the way behind you. So out of these 3 locations of the sun, you're looking for the one that's lower to the ground, and just thinking that there's going to be no trees or no obstacles like buildings in the way. So for this, it's going to be path X gives you the biggest shadow. 14, what is one possible date that is represented by path X? So again, we're really talking about path X in this diagram. Since path X is low in the sky and it has the smallest or shortest amount of length in the northern hemisphere, it's going to be giving us less sunlight. So when it's giving us less sunlight, that's going to be our winter months. So we have to find which date is with our winter months, okay? And for this, it gives us December 21st, which is actually the date that we have the shortest amount of sunlight. Okay? And then for 15, it says, what is one possible date that is represented by path Z? So now path Z, that is the longest travel time for the sun. So the sun's going to be out most of the day. So for this, we got to find which month do we have the most sunlight, and that's going to be in June. So June 21st. Okay, and that's going to be the most. All right, so now if we flip this over, and again, you can always pause the videos to look at the diagrams, and the diagrams are a lot better on your packet. Okay, so now for this one, it's giving us the sun's rays. So we have actually three parts. We got 1, 2, 3, and they represented A, B, and C. So for this one, it's showing that the Earth's is getting the sunlight directly overhead, okay? So this is the sun's rays, and it tells us that it's 90 degrees, so it's directly overhead. It's directly looking down. Now for B, it's telling us that the sun's rays are hitting at an angle of 66.5 degrees. And then for the last one, C, it's showing us that it's really hitting at an angle or lower angle, and it's 43 degrees. So for this, we have to say, as viewed in sequence A, B, and C, these diagrams represent which months which change in the intensity of insolation, okay? So we're looking at basically the sun's rays, they're becoming less strong in that area if you were living right here. So if you were here, you're getting direct sunlight, now you're getting a little bit less, and now much less. So we have to figure out, if you're getting strong rays, this is probably going to be a warmer month of the year. So we have to find one that starts with June. Now we get over here, the rays are less strong, so it's not going to be as warm as the temperature. And now it's probably going to September, and then it gets to C, and it's going to be December. And as it's going down, it's decreasing. So for 16, it's going to be C, okay? So you're going from June to September to December, and you're also decreasing in intensity of the sun's rays. 17, as the angle of the sun's rays strike Earth's surface at noon changes from 90 to 43, the length of the shadow cast by an object will. So this is really important. This is going back to the shadow questions, okay? So if you're over here and it's directly over your head, your shadow is going to be basically right at your feet. Now, if you're standing over here and the sun is coming from the right side of the board, your shadow is going to go all the way out. So basically, as you change from position A to position C, your shadow is going to increase. Okay, so now the next questions have to do with, again, they give you the same diagram. They give you your horizon. All right, they say, again, this is north, south, west, and east. And it's giving you 3 pathways of the sun again. Okay, so they give you where it's a short one, and they're saying that that's December 21st. Then they give you one that's a little bit more, and they're giving you that it's March 21st. And then the last one goes a little bit higher up in the sky, and they're saying that that's June 21st. Okay, so for this one, we're looking at, it says, draw an X on the diagram to represent the solar noon position as seen by the observer on May 21st. So May 21st, okay, you have March and you have June. It's going to be somewhere over here. So you're actually, your line, because it's slowly moving up, it's going to be somewhere over here. And solar noon, it's always going to be the highest part in the sky. Now, 19, identify the rate of the sun's apparent movement in hours along its path on December 21st. So we're using the smaller path, but regardless of what path we use, when our Earth rotates, everything in the sky is moving, except for Polaris, 15 degrees per hour. Identify the compass direction at which an observer's shadow would point at solar noon on March 21st. So March 21st, your solar noon is when the sun is highest in the sky for that date. Now, if you are an observer and the sun is going down, remember the sun is always at every single location in New York State. It's always south of us. It's never directly overhead. Even when it's June 21st, our longest day, it's still south, just not as much as if it was December 21st. So our shadow is always going to be pointing north. So for number 20, the compass direction, our shadow is always north, unless we're in the southern hemisphere, and then it changes, okay? But for the northern hemisphere, where we are, basically everywhere in the United States, it's always going to be north. Using the diagram below, which date has the greatest number of nighttime hours? So nighttime hours, that's when the sun is going to be the least amount of time, spend the least amount of time in the sky. And for that, it's going to be December 21st, okay? That is when we get the shortest amount of sunlight during that day. All right, so the last three questions on the last page. So for this, they give us Polaris, okay? So Polaris is our North Star. So when we're looking at Polaris, Polaris never moves as the Earth rotates. Everything else moves around it. So if you have a photograph and you're taking a bunch of pictures per second, and then you're showing that and you're putting into one picture, you'll get something like this graph where it has the lines moving, whereas Polaris just stays in the same position. So for this, it says identify the rotation of the Earth or the motion that causes these stars to appear to move in a circular path. So the motion for number 18 that's causing this movement in a circular path is the Earth's rotation. Now for 19, it says determine the number of hours, excuse me, number of hours it took to record the star trail labeled on the diagram. So the star trail is any one of these. Okay? Now what you have to do is you have to look at the graph and figure out how many degrees each one of those are. And if you're looking at it, you'll find that each one of them, if they're far out, they look longer, but they're still only 60 degrees. And then if you look closer, it's still 60 degrees, it's just more condensed, okay? So you get that it is 60 degrees that each one of these star trails have traveled. So, but we have to find out how many hours. So 60 degrees, and we know that 15 degrees is 1 hour. So we're going to divide that by 15 degrees, and you end up getting 4. So it's going to be 4 hours. So this photographs the whole length that they were looking at this at Polaris and all the stars rotating around it. This is just 4 hours. Now, if we went all the way to 20 or 24, right, a full day, all these stars would be a perfect circle going around Polaris. And then the last one, it says, what is the latitude of Polaris when it is viewed from the top of New York State, Mount Marcy? So for this, we're going all the way back to Q2. So what you're going to be doing is you're going to use your Earth Science Reference Table, and you're going to go to page 3, and you have to find out where Mount Marcy is, and it's all the way up here located. And you have to find out what the latitude is. And you end up getting 44.2 degrees latitude, okay? So these were the questions in the packet. If you have any questions, please let me know. Contact me on Google Classroom. I'm going to be uploading another thing later tonight. I just have to go into the classroom and get some stuff. And then we will go from there, okay? So we're going to start going into different universes and then basically the whole universe as a whole, not just the solar system. So now we're leaving the solar system. We're going to go on to all the other stuff, okay? All right, guys, I'll see you later.